Hey everyone, hope everyone is doing great. It's been a while. I think I took a short break. Uh, it's going to be a relatively short video today where I'll go through what we have done in the previous lectures and a quick walkthrough around of how do we update the input values based on gradients in order to see how the loss is being minimized. It's going to be a quick 5-minute video, so just stay with me here and let's get started. So if you read, we have calculated what the respective gradients should be based on the loss. So we calculated the gradients using differentiation or derivatives with this specific formula where you nudge your input x by a small value h to see how much of a change or response did x have. That's a standard derivative used to function where in a way we said a DL. We calculated what is the effect of partial differentiation here. For example, we said dl by dA, the change in L with respect to A, the input, is equals to dl by dE. How much does L dE by dA? How much does E change with respect to A? So this is a chain rule that we've discussed last time. And yeah, in that way, we have calculated the gradients for each of the inputs or each of the values that are present in our network, right? So in this video, I'm going to walk through on what to do once we have these gradients. In with the rest, so that we hope our loss reduces or it converges to zero. Let me show you what do I mean here. So now that we know what's the response of each of these weights present in the network with respect to L, I mean, how does L gets affected when we nudge any of these input values? Now, what are the input values here? The input values here are A, B, A, B, C, and F. The values E and D are one of the outputs that that are basically addition or multiplication of the inputs. Hence, we can only change these inputs A, B, E, and F. So we know how much we should change. We have these values here. So let's start by doing A equals to. So we are basically adding the gradient to A. And we cannot directly just do A dot grad because if we go back to the basic way on which we calculate or we need to take a step in gradients. So if you remember this plot, we calculated a gradient and it's said to move in some specific direction. And the whole equation will be fluid and magnitude, but don't totally take the whole magnitude, but we take it on a small proportion of a step or of a magnitude of the gradient. So that gradient is rightfully pointing us towards minimal loss. That's true. And we have the direction here, positive or negative, and also gradient tell us by how much value it should be changed. Like the wave calculator, right? Change by like, so these steps could be a bit too much, and instead of taking one step closer to the minimum loss, we might jump off to somewhere else. Hence, we need to take a very small step into that direction. And that's the reason why we just multiply with a constant, which is known as in the with the gradient, and then so I'm going to update B as well, and then we have C and F, right? So C and F. So with this, we are updating our weights. Now, when we update our weights and then use this new weights into the equation, basically is A into that gives rise to D, and D plus F that gives rise to L. So let me do this forward pass, as we call it. E is equals to A plus B, and then we have D is equals to E plus F, and then we have L, which is equals to D into F, right? So, okay, do D, okay, and then A into B is equals to E. Perfect. So once we do that, what are we expecting? We're expecting that our ultimate L, which is loss, something that we would like to minimize, it starts getting closer to zero. So let's see how much of a L change is happening. Restart this and let's run everything. So it's pretty evident that the loss has reduced from 8, which is used to be initially, to minus 6.5. So that's basically one iteration of feed-forward neural network that we have implemented with gradients derived from the weights that has been updated, the input weights, and after the for feed. And if we keep to showing how one iteration of backpropagation works in a neural network. And in the next video, I will actually walk you through the weights and inputs and adding bias, and actually starting with a proper neural network formulas along with activation functions. So yeah, it's going to be an exciting time. Thanks for sticking.